Hi, this video is about coupling in programming, specifically tight coupling. It can be a reason why codebases are difficult to work with, difficult to change, why entire codebases can turn into big balls of mud, why code can become badly readable or just no fun to work with in general. Parts of it can become unmaintainable or not reusable. Lots of things that you truly want to avoid. I'll talk about what coupling is, how coupling can be no coupling, loose coupling, tight coupling, and I'll talk about it with loads of examples. And in the end, I'll talk about mechanisms and design patterns to reduce coupling as much as possible. Let's get into it. So let's talk about what coupling actually is. Coupling is defined as the degree of interdependence between software modules. And I always like to think of this in simpler terms. I ask myself this question: if I have two, let's say, functions, to keep it simple, function A and function B. Function A calls function B. And to think about the coupling, I ask myself the question, if I want to change B, would I also need to change A? How much can I change B without needing to change A? This is the way you can explore the relationship between these two things. Let's look at an example. I've made these examples as simple as possible to get familiar with the vocabulary. So in here you can see tight coupling from A to B and no coupling from B to A. A needs B to be defined. It needs to be a function, it needs to be callable, and it needs to adhere to a certain interface. There's no coupling from B to A. Right now it has no implementation. It does not need A in any way. Let's look at another one. So in here I've got a store object, a different A and B function. They both have access to a store, but they're not calling each other anymore. There's no coupling from A to B. A and B work independently. There is a chance of naming collision in store. They're both writing to store in this case. What if they would also read to store, or what if they would write to the same property? There's a chance of naming collision. There is coupling, tight coupling, from A to store and from B to store, because they are accessing this property in direct reference to store. It's mutating some original. The third example, I have another store, but now I have loose coupling between A and B. A and B both operate on the numeric counter property. They will not error when it does not exist because it has a default. So I would call that loose coupling. There's again tight coupling from A to store and from B to store because they exactly are as the same as the previous example. They are accessing a direct reference to the original store. And the last example, I have no coupling between A and B. A and B work independently. In this case, I have different stores for every run. These have become pure functions. A returns a new object. Object assign is used in this case to assign the properties of all the following arguments to the first argument. So it would return a new object, first populated with store and then with the foo property overwritten. For B, it's the same but with only the bar property overwritten. So the result in this case is that there's no coupling between A and B, and there's loose coupling from A to store and from B to store, because the store is injected as an argument, DI, dependency injection, and it is immutable. It's returning a new object. It's returning a new store each time. It is not mutating the original store. And again, there is a small chance of naming collision if they would write the same property to that object. Maybe the call site in this case needs a store property, and therefore it could have a naming collision. But this is the least amount of coupling in this tiny example. Coupling is really everywhere. You can think of coupling in the small things, and you can apply it in the very large things. Let's talk about a few. I'm going to talk about functions, classes, then APIs, and even clouds and architecture. Let's look at the small ones first. Right here we have a function that reverses things. It can be either a list or a string, and it returns the list or string with the elements in reverse. This function is tight coupled to the isString function. It's as simple and plain as that. We've seen this example, it's the first example. A is tight coupled to B. B has no coupling to A. It just needs this to exist. This could be in some util file. This could be somewhere else, like my string utils or my types utils or whatever. That module might have other functions there, and then this makes sense because you're reusing this function all around your code base. These things happen very often, and if you have a reverse function like this, it makes sense to depend on reusable like isString. Let's look at the object example. So right here I've got a class controller which is tight coupled to the MySQL connector. This controller has an index page function and it is instantiating a database connector. It's passing the credentials via the environment and it's then executing a query. Because it is instantiating this thing itself, it has a hard dependency on this class as a whole, on its interface, because it needs this name to exist, it needs it to be defined, it needs to be able to pass its credentials in a certain format, it needs to retrieve a database connector, which again is a object that it can call a query method on. It's depending on everything that is the MySQL connector. This is a tight coupling. If we would refactor this into a less tight coupled one, a more common way of doing this is actually to put an interface in between and to have the database, instead of the controller instantiating the database, creating the database instance itself, it would be passed the database instance as an argument. This is called dependency injection. This moves the responsibility of creating the instance of the database connector to the call side. So the user of the controller is now responsible for creating the database connection and then passing that to the controller, which is then using it. This decouples the controller from the database connector in this case. All of these are examples, of course, but you can already see that it still does depend on the interface of this query. It needs to be passed a string and it can return. Okay, in this case I didn't put any types in, but you get the idea. You can also think about coupling on a larger scale, such as when thinking about APIs or whole systems. Say you are working on an application that is working with an API. That API is being called by your application. That API can be a very specific or unique API. It can also be a very generic API. You can ask yourself the question of how much coupling you have between these two systems by, again, looking at if that API changes, how much of my application would I need to change? Do I need to rewrite my whole application? Because almost every part of my application is depending on how this API is specifically implemented, depending on details of it. Or would I only need to change like one or two classes on the edge of my application because I'm only there depending on specifics of the API and the rest is just generic stuff? That would be tight coupling versus loose coupling. You can also think of the API as a generic thing. Some APIs are very generic. Selenium WebDriver is a nice example of this. It's a way to automate browsers, as if the script that's automating the browser is a user. You can click around and navigate and whatnot. Selenium WebDriver is a very generic API. If you would have an application that's calling that API that is now using Firefox, you might easily swap it to using Chrome because it's the same API. That's the advantage of using a generic API. It's loose coupling towards the browser, tight coupling towards the interface of WebDriver. When thinking about coupling on an even larger level, like with cloud and architecture, two examples come to mind. The first is Docker. Docker is a way to decouple your application from the operating system it's running on. You don't need to depend on the specifics of an operating system. You can now run your executable inside a Docker environment, which is this intermediary layer between the application and the operating system. And now it doesn't matter what operating system you're running on at all anymore. You just need this Docker OS, and that's all you depend on. Another example is infrastructure as code. Say you are provisioning a database. You're creating a database via automation, via code. A popular way of doing this is AWS CloudFormation. AWS CloudFormation, of course, depends on AWS. It will not work on any other cloud. An alternative tool like Terraform which exists because it is cloud agnostic, will allow you to write code that is more loosely coupled towards the specific cloud you work on. You might be able to more easily switch clouds. It will still have a cost. There's not no coupling. There's some coupling that's loose coupling, but it's a big improvement if you might want to switch clouds. Something that coupling is often contrasted with is cohesion. Cohesion is defined as to which degree are elements inside a module, for example, functions inside of class, to which degree are they related to each other? To which degree do they belong together? Let's look at a picture. So I have 4 boxes here. These can all be thought of as modules, maybe classes. And the dots in here are all functions or methods. These have links to each other. The best practice of coupling and cohesion is it's good to have loose coupling and high cohesion. High cohesion is that these dots really belong together. The grouping of these functions inside this class makes sense. They are related to each other. There's similar functionality. They achieve one task together. It is bad to have high coupling, low cohesion. In this case, you have these functions don't really belong together, and there's lots of dependencies here. If you change this method, suddenly there's 2 methods or functions that need to change here, but this is another class. Why are these together in this way? This is often considered bad, but it isn't black and white. The next thing I want to talk about are the mechanisms and patterns to reduce coupling. And the first thing to realize here is that by already knowing about coupling, by learning about what coupling is, there are already many ways you can probably think of yourself. How can I reduce coupling here? You can think of this in terms of refactoring. If you know system A will change, class A will change, function A will change, you are using it from system function B. If this will change, how can you decouple? This is right now tight coupled. What can you do there to improve your situation? And also when designing new solutions at the beginning of the process, when you're thinking about your solution direction, when you're thinking about what interfaces and how you're gonna actually implement this problem, this user story, this task, you can think about the coupling at that point in time. You can talk about it with colleagues. You can, in a merge request review, it might be a good thing to, from now onwards, whenever you do a merge request review, to consciously ask yourself, what kind of coupling am I dealing with here? Are these 2 parts loose coupled? Are they tight coupled? How would I know? Can you discuss this in your merge request review with your colleague or peer? Another great way to reduce coupling is to not depend on any internals of a module, but only depend on its interface, preferably a single interface. You saw this in the image when we talked about low coupling, high cohesion, where there was only one connection point in that first example, and there were many private methods behind that. That is okay, that's the high cohesion part. If we can only have one connection point, that would be an easier way of doing things. My third recommendation is to abstract if you want to reduce coupling. You saw this in my previous example where the MySQL connector became a database connector. Database is an abstraction of MySQL. Right now the controller is not depending on a specific database anymore, it's depending on a database, which could theoretically become a different database in the future. Now do realize that it will require work. If you want to implement a new database connector, then if you want to connect it to PostgreSQL, you need to implement another connector. And it better adhere to that interface, otherwise you would still need to rewrite your controller. And also realize that this has a cost. Putting interfaces everywhere throughout your code isn't necessarily going to make your code better. It will require time to do this, and it will always also convolute what's actually going on. You might end up with lots of code that is more complex than what's actually necessary. You might want to decouple your controller from your specific database implementation, but it isn't always a good idea. Another way to control coupling is to look at it from a perspective of data structures. First, in a sense that data structures can be used to decouple two pieces of functionality, two modules, two classes, two functions, by putting a data structure in between. A classic example of this is a queue. If you have a data pipeline, multiple functions are passing this data object around, applying transformations, passing it to the next. You could decouple two of these functions halfway in this pipeline by putting a queue in the middle. Suddenly these functions depend on the queue. The first function depends on a queue to put things on, the other one depends on a queue to take things from. This introduces the complexity cost of suddenly things are often asynchronous, but it introduces the generic queue structure. Depending on something generic often has a lower complexity cost and a higher maintenance agility, so to say. You can more easily change the code. You don't depend on specifics anymore, as opposed to depending on each other. The second way to look at data structures is that data structures themselves can also be coupled to. So the examples I've given up until now are all about functionality having coupling to other functionality. Function A is using function B. But in reality, we're often coupling functionality towards a data structure. If you have a complex data structure, nested objects and lists and whatever, and you have multiple functions depending and being coupled to that data structure, using that data structure, then it becomes very hard to change the data structure. All of this is tight coupling towards the data structure. This is also a very bad way of designing your code on a larger, grander scale, because again, it's more difficult to change. And my last tip is to learn about which design patterns can help you reduce coupling. Design patterns such as dependency injection, the proxy pattern, the facade pattern. There's many others out there, but it's an exercise to learn about these patterns and how they can help you manage coupling. To summarize, start thinking about how different parts of the codebase are coupled and how you can reduce this coupling, and start conversing, start talking about other people about the coupling, start using it in your merge requests, start actively think about, is this code coupled in the way I want it? Is this tightly coupled right now? Do I want to move this to loose coupled? The answer isn't always yes. Remember, there's a cost to removing and to increase all these interfaces and whatnot in your codebase. And learn about the mechanisms and the patterns you can use to reduce coupling. And that's it. Thank you for watching. I hope this was useful. Please let me know if you have any thoughts or requests for things you'd like to see in the comments. And I hope you have a great day.